Myself, Dr. Naresh Kumar, Department of Mathematics, Institute of Engineering, Aeronautical Engineering College, Dundigal, Hyderabad. Today, I discuss the topic which is most important, that is differential equation. This is the topic of mathematics, and now, first of all, we discuss about the definition of a differential equation. What is the definition of a differential equation? Means an equation, any ordinary equation in which derivatives or differential coefficient involved is called a differential equation. Otherwise, second definition of differential equation, we can say that a branch of mathematics in which we study of a relation between derivatives of different orders and degrees with function of dependent and independent variables is known as a differential equation. Suppose I am giving example. I am writing a relation between differential coefficient dy dx and is equal to x plus y upon x minus y. So this is the differential equation. Why we can say that this is differential equation? In this differential equation, here is derivative present and two variables present. One is x variable, other is y variable. Here in this derivative, differentiation of y with respect to x. So here y is dependent variable and x is independent variable. So this is the derivative, or we can say this is the differential coefficient. So this relation is known as a differential equation. Now next, other example, d2y over dx2 equal to sin x plus 2x plus a. So here a is constant, x is independent variable, sin x is function in independent variable, and y is dependent variable, and x is independent variable. So here in this differential equation, the differential of y with respect to x 2 times. So this is the differential coefficient of second order. So in this differential equation also involve derivatives or differential coefficient, and functions or variable also involved in this equation. So this equation is known as a differential equation. Means our motto or relation, in this relation there should be derivatives and there also involve variables. One is independent variable and other is dependent variable. Next one, for example, I am giving here some example. Suppose here x plus 1 and into dy upon dx equal to x y square plus 1. This is a relation. First, here is first differential coefficient in this relation and variables are present x and y. So this relation is known as a differential equation. This is the example of a differential equation. Here in this equation, the derivative of y with respect to x is 1 time. So this derivative is first order derivative. So this differential equation is known as a first order and first degree differential equation. Now in second example, here d2y over dx2 equal to sin x plus 2x plus 3. So in this equation also the derivative of second order, and here is also function with independent variable, and this relation is known as a differential equation. Next, this is a partial differential equation because here is the derivative of second order with partial. This is also partial and this is also partial. So these are partial derivatives are present in this equation. So we can say this equation is partial differential equation. Now, types of differential equation. Here I am giving some example which are represent the all types of differential equation. Now we discuss how many types are differential equation. Basically here two types of differential equation. Number two, ordinary differential equations and partial differential equation. So what is ordinary differential equation? Ordinary differential equation means there I am writing some examples. Dy dx and plus 2x plus 3 equal to 0. This is the differential equation. In this differential equation, only one dependent variable and one independent variable. So in a relation, there is only one dependent variable and one independent variable. That is known that equation is known as a ordinary differential equation. And the derivative of ordinary differential equation represented by d over dx, and that is represented by capital D. So dy dx means here is only one independent variable and only one dependent variable y. So this is ordinary differential equation. Now in partial differential equation, there is one dependent variable and more than one independent variable. In this function is lie here z equal to function is x comma y. So here we differentiate z is dependent variable here and x and y two independent variable. But here may be more than one independent variable. More than independent variable means there may be 2, 3, 4 up to n. There may be an independent variable. What single dependent variable? This dependent variable z depend on x and y. So now we can differentiate the z with respect to x and with respect to y. So if we differentiate this derivative z with respect to x, then here y is constant, y keeping as a constant. So f dash, we write a f dash x only, x, y is constant. Now if we differentiate with respect to y this, then we write this f dash x comma y. Here y constant and here x constant. We differentiate with respect to y, then x as a constant, and we differentiate with respect to x, then y as a constant. So in a relation, if there is partial coefficient are present and more than one independent variable and only single dependent variable, that equation is known as a partial equation, partial differential equation. Now I want to definition of a ordinary differential equation. What is the main definition of a ordinary differential equation? So an equation in which differential coefficient involved and two variables are in this relation, or two functions may be there, only one independent variable y and only one independent variable x. Here y is dependent on x. So basically here function used as a y is equal to fx. This is the function. In ordinary differential equation, the type of the function is this. In this function, x is only one, x is only one independent variable. Only one independent variable. And y is only one dependent variable. Dependent variable. This is dependent on x. So here this derivative is known as a dy over dx. Dy over dx. That is represented by capital D. And d2y over dx2, that is represented by d square y, and this is dy. So now a relation in which differential coefficient involved and there are two variables or two functions, in one is independent variable x and other is dependent variable y, and y is dependent on x, and in this differential equation the form of the function is y is equal to fx. Y is equal to fx means there are only two variables, x is independent variable, and y is dependent on x. So the derivative of this function is represented by ordinary derivative or ordinary differential coefficient. Here we are given several examples of ordinary differential equation dy dx equal to 1 plus y square upon 1 plus x square. This is the first example. And second example is d2y over dx2 equal to sin x plus 2x plus 3. Third example is x plus 1 dy dx equal to x into y square plus 1. So there are, I have given three examples on depend on ordinary differential equations. Now next, second is definition of a partial differential equation. How we can define a partial differential equation? So an equation in which partial derivative involved and one dependent variable z, only one dependent variable z, and more than one independent variables lie in a relation in an equation, then that equation is called a differential equation. So here I am telling you basically z is dependent variable. That is a dependent variable. And x1, x2, x3 and xn are independent variable. Independent variable. So z is a function of, there are x1, x2, x3, x4 and dot xn. So this is the function. Basically this in this function only single variable z, that is dependent variable. This is dependent on x1, x2, x3, x4 and xn. What x1, x2, x3, x4, xn, there are n independent variable. So here we can differentiate this function first time with respect to x1, second time with respect to x2, third time with respect to x3. Similarly, we can differentiate with respect to xn. And when we differentiate with respect to x1, then other r variable as a constant. We are taking r other variable as a constant. So now we differentiate del z over, this is del z over, this is partial derivative, del z over del x1. So this is f dash this and this result. The other are same here. Function is unknown, so we write here only dash. Dash means we differentiate with respect to x1 and other variable keeping constant. Now again differentiating with respect to x2, then here f dash and we are writing same here. So we differentiate with respect to only x2, only here x2, other variable keeping as a constant. So this is the partial derivative. Now here in this discussion we have taken n variables independent, n independent variables, only one dependent variables. Now I am giving example of only two independent variable and one dependent variable. So I am taking z is only one dependent variable z and two independent variable x, y. So now here is only two variable, I am taking x and y. So we differentiate here with respect to x, then y constant, and with respect to y, then x constant. So del z over del x, differentiate of z with respect to x, then we find f dash x y. In this function y is a constant, y is constant. And next del z over del y, with respect to differentiate of this z with respect to y. So answer is f dash x y. So now x is constant. X is constant here. So these are del z over del x and del z over del y. These are partial derivative with respect to x and with respect to y respectively. So now here in this partial differential equation, del z over del x represented by small p and del z over del y is represented by small q. So these are first order derivative with respect to x and with respect to y respectively. P and q are basically in mathematics in differential equation, small p and small q are represented by first order derivative, first order and first degree derivative with respect to x and y respectively. If we have, suppose I am giving one example of partial derivative, z equal to is f x comma y. This is function. So we want total differential of z here. Total differential z means here dz, this equal to f dash x and dx plus f dash y, f dash xy dx and f dash xy into dy. So this is p and dx, this is q and dy. P dx dz equal to. So dz equal to dz dz equal to p dx plus q dy. This is known as a Euler's equation, Euler's differential equation, that is in partial derivative, partial differential equation. Euler's proof or differential equation of first order, that is known as a Euler's differential equation. Next topic, I am discussing the application of ordinary differential equation of first order and first degree and higher order and first degree. There is a wide application of differential equations in all engineering branches, like as electrical communication engineering, civil engineering, electrical and electronics engineering, computer science engineering, aeronautical engineering, and mechanical engineering, and other several branches of mathematics. We are using a differential equation. Ordinary differential equation also be used in physics and as well as in chemistry. Some topics are given as follow, which are based on differential equations of first order and higher order of the first degree. First order and higher order of the first degree. Where we are using first order and higher order of the first degree differential equation in engineering branches. So I want to discuss this topic. So here CR circuit. In CR circuit, a wide role of first order and first degree differential equation. LR circuit, there is also first order and first degree differential equation. Next, LCR circuit. In LCR circuit, we are used a differential equation of higher order and first degree differential equation. Newton's law of cooling, equation of motion, simple harmonic motion, Newton's law of motion, and velocity, acceleration, radial velocity, transverse velocity, radial acceleration and transverse acceleration. In all above topics, there is a wide application of the differential equations. Suppose simple harmonic motion. I am discussing that how we use a differential equation in simple harmonic motion. Means suppose a particle start from a point this A and goes to point B. So here is displacement is covered by particle as x, and acceleration is d2 at a d2x over dt2. So here this is acceleration. So acceleration d2x over dt2, this proportional to minus x displacement. This is the acceleration, 2 time derivative of x with respect to time, and this is only one independent variable x and t is independent variable. So x is dependent on t, time is independent variable here. So d2x over dt2, this is the acceleration of the particle which are moving in a line. So at any point, this is the acceleration, and displacement is x. So simple harmonic motion, the acceleration of a particle proportional to negative of the displacement. So d2x over dt2, this is equal to, I am taking here minus mu square. Mu square is proportional constant. So mu square is proportional constant. If we remove of proportional, then we are taking here constant. So we taking mu square here. So now d2, this is represented d square x and plus mu square x equal to 0. So d square plus mu square and x equal to 0. So now writing auxiliary form. auxiliary form here. So here m square plus mu square equal to 0. So m square equal to minus mu square. So m square equal to I square and mu square. So m equal to plus minus I mu. So here this is the roots of auxiliary equation, m equal to plus minus I mu. So here we find the CF complementary function. This is equal to x C1 cos mu x and plus C2 sin mu x. So this is the solution of, this is x equal to solution of simple harmonic motion. X is displayed here is t. This is mu t and this sin mu t. So this is the solution of simple harmonic motion equations. Here is x is displacement, here is time is, this is t is time. So here we are showing that in simple harmonic motion, we are using a differential equation of second order and first degree. Similarly, one formula, Newton's law. This is F equal to ma. This is formula, F equal to ma. So here we are also using in when a particle is moving. So F, m and a is acceleration. Suppose any particle moving on any line and there is we applied some force on the particle, and after applied force there is some displacement in the particle. Suppose displacement is x, then acceleration, displacement, there is change in displacement, then we get velocity in the particle as well as we get acceleration of the particle at any point at any time. So here acceleration means d2x over dt2. So in this formula, F equal to ma, m is the mass of the particle and a is the acceleration of the particle. When we applied the force on the particle, then there produced some displacement as well as some produced in velocity and acceleration also there. So this is the Newton's second law, F equal to ma. So here several radial velocity, radial acceleration. In all topics, we can use ordinary differential equation. Now, next topic we discussing what is the differential coefficient or derivative. This is the basic of this differential equation. Without differential coefficient, without derivatives, we cannot understand a differential equation. Either that partial differential equation or ordinary differential equation. For every equation, we know the derivative. We are discussing here only ordinary differential equation. So in ordinary differential equation, there is only single dependent variable and only single independent variable. Dependent variable is y, is dependent on independent variable x. So here we are taking the formula function y equal to fx. Any function y equal to fx here. So now, how we can define a derivative? Suppose this is point A. Here the position of the point is x comma y, x comma fx. Fx means x comma y. Fx is always y. I am giving here equation y equal to fx. So fx is represented by y. Fx is some function and some function is represented always by y is function of x. So particle at V, this is the another point. Another point is there is some displacement, x plus delta x, some increment in x plus delta x, and also increment in function. Then function becomes x plus delta x. This is the x f of x. Here x change in x plus delta x, then also fx change in fx plus delta x. So here is AB. This is AB line. AB line. So AB line basically slope of line. Here we discuss slope of line. Slope of a line. What is slope of a line? Slope of a line means change in displacement between A to B. Formula is dy dx. This formula, this is slope. y2 minus y1 upon x2 minus x1. This is the ratio of, this is ordinates. In numerator is difference in ordinates and denominator is difference in abscissa. So every point represented, value of y is ordinate and value of x is abscissa. So this is the basic formula of slope of a point. If two points are given on the line, then we can find dy dx. Dy dx basically slope of line. So 2 point y2 minus y1, y2 here, this y2 here, fx plus delta x, and minus here fx. This is value of y1, this is value of y2, and here is x plus delta x, and minus this x2 minus x1. x2 is x plus delta x, and x1 is x. So x is cancelled. But a and b are very neighborhood points. Means they are represented the limit. Limit means b tends to a. B tends to a means there is very minimum distance. So we are showing here limit. Limit delta x tends to 0. So this result is limit delta x tends to 0. Here is, this is delta y. Here it changes, that is delta y upon delta x. So this is represented delta x tends to 0. So this is dy over dx. Delta convert in d after removing the limit. Delta convert in d. So that is dy over dx. So this is the slope of a line. So this is the derivative. This is the first derivative. Means we are taking derivative between 2 points, then that is first derivative. This derivative involved in any relation that known as a differential equation. And this is the differential coefficient. Now second order differential coefficient, again same type we can use, then we find second order derivative. For example, here we are showing that for y equal to fx, this is some function. In this function, x is independent variable and y is only dependent variable in x. And then dy dx and d2 by dx2 are known as a differential coefficient of first and second order respectively. We are showing here different differential coefficient and different orders there. So here dy dx, I am writing dy dx. So this is first order differential coefficient. And next one d2y over dx2, this is second order coefficient. d3y over dx3, this is third order coefficient. Similarly, we can write dny over dxn, this is n order differential coefficient. Here is n time differentiating of y with respect to x. So this is the differential coefficient of n order. Now order and degree. This is also most important topic. In this topic, we have discussed that given differential equation, what is the order of that given differential equation and what is the degree, order and degree of a differential equation. So there is several degrees of a differential equation, but we have separately defined one by one. So order, what is order? Order of a differential equation means definition. The order of a differential equation is the order of the highest order of a differential coefficient. In any differential equation, we see that how many highest order. There are several terms in our differential equation. Means there are 3 terms, 4 terms, 3 terms, 2 terms. In all terms, we are checking the derivatives. Derivatives are in 2 terms, 3 terms. Then we check that how many highest time derivative, highest time differentiation of dependent variable with respect to independent variable. So that is the order. We see the highest order derivative in a differential equation with respect to independent variable of dependent variable. Suppose here I am giving some example. Next is degree of a differential equation. Degree means in a equation, in a differential equation, the highest power of a highest order derivative. Means any differential, I am giving some example here, dy over dx and this whole square and plus d2y over dx2 and plus 2x plus 3 equal to 0. I am writing this type of equation. So what is the order and degree of this differential equation? So there is no problem to tell the order and degree of a differential equation. That is very easy. First time order, we check the order. Order means in which term the highest order derivative, maximum time differentiate of y with respect to independent variable x. So we see that in first term. First term is only dy dx. Here is one time derivative of y with respect to x. Now in second term we have d2y over dx2 means two time derivative of y with respect to x here. So this is the order, maximum order in second term. In second term is maximum order, two time derivative of y with respect to x. So order of this differential equation is 2. Order is 2. Order is 2. Now next, what is degree? Degree means we check the power of highest order derivative. So the power of this derivative is 1. So degree is 1. Degree is 1. What one point is note that when we are checking the order and degree, then there will be no power in fraction. Fraction means 3 by 2, 1 by 2 and 1 by 3, 1 by 3. This is not acceptable. 1 by 3 and 1 by 2, 1 by 4. This is not acceptable here. Only numerical power 2, 3, 4. This type of power is acceptable. Rational power is not acceptable. If rational power is given in our question, then first of all we change the rational power in number power. Now for example, order and degree of following differential equation. I have given some example here. So how we discuss the order and degree in given differential equation, how we check the order and degree. Now in example 1 we check this cos x and d2y over dx2 and plus sin x dy over dx ka whole square and plus 8y equal to sin x. This is the differential equation. In this differential equation we check that in which term in differential coefficient how many maximum time differentiate of y with respect to x, 1 by 1. So here is only dy dx. Dy dx means I am already tell you in dy dx only one time derivative of y with respect to x. In first term we see that here is d2y dx2. So d2y over dx2 means here two time differentiate of y with respect to x. So here is order 2, here is order 1. So maximum order in first term. So if we want to check the order, then we see the how many highest time differentiate of dependent variable y with respect to independent variable. So here two time, highest time is two time differentiate here. So the order of this differential equation is 2. Order is 2. Now degree. So the power, we check the power of this order, highest order derivative power. Not other. Here is 2 power, but here is 1. Here is single derivative. Here is single derivative, but power is 2. Here is double derivative, but power is 1. So degree is here 1. Degree is 1. So order and degree, order is 2, degree is 1. Now in second question here, 3 time derivative, second example. d3y over dx3 ka whole 4 and minus 6x square dy over dx whole to the power 8 and equal to 0. Now this is very interesting question. There are only 2 terms in this question. In second term, there is dy over dx only. I am discuss dy dx here. Dy dx is first order differential coefficient. So here is first order differential coefficient. But power is 8. Power is 8 here. But here is d cube by over dx cube. Means third time derivative. Third differential coefficient is this. 3 times we differentiate of y with respect to x here. But the power of this is 4. Order is greater to this, but power is less to this. But we check the highest order derivative in a differential equation. So highest order derivative in first term and highest order derivative is 3. So order is 3. and the power of this highest order derivative is 4. So degree is 4. Degree is 4. Now I am giving one example in which the rational powers are there. Suppose here I am giving 1 plus dy over dx ka whole square whole to the power 3 by 2 equal to d2y over dx2. I am giving this one differential equation. So what is order and degree of this differential equation? So here is total whole power. Whole power is 3 by 2. This is rational power. So we are removing this power. How we can removing? Squaring on both sides. Squaring on both sides. When we squaring on both sides, then this equation convert in dy dx ka whole square, this ka whole cube, and equal to d2y over dx2 whole square. Squaring on both sides. So now a plus b ka whole cube, we can open this result. We can open this result means then now order. Here is 2 time differential. Second order differential coefficient in this term. Here is first order differential coefficient. After opening this power, there is no change in order. Order is same, this power is change. So now here is second order derivative. Highest order derivative is second order derivative. So order of this differential equation is 2. And degree, the degree of this power of this derivative, highest order derivative is 2. So degree is 2. Order and degree of this equation is. Now similarly third example is x square d2y over dx2 ka whole cube and dy over dx ka whole 4 plus y into dy over dx ka whole 4 plus y 4 equal to 0. So now we check the order and degree of this differential equation. Ordinary differential equation. Here is second order derivative. In first term is second order derivative. But the power is 3. Next term is first order derivative. But power is 4. But now if we want to check the order and degree, so we see the highest order derivative in a differential equation first time, and we check the power of highest order derivative. So highest derivative is this d2y over dx2. So in third example order is 2 and the power is 3 of highest order derivative, so degree is 3. Now here I am giving some examples of rational power. If in our question there is some rational power, so how we can check the order and degree? So here I am just telling before this question, here the order a whole to the power 3 by 2 equal to this. So first of all I am squaring on both sides and here whole square, so this order 2 and degree 1. Now this result, example 2 I am telling you, 1 plus dy over dx ka whole cube and whole to the power half equal to, this is 1 by 2 power, equal to dy over dx. So this is the differential equation. Now here we removing this half. Half is rational power. So squaring on both sides. Squaring on both sides. So here we get 1 plus dy dx ka whole cube and this equal to this whole square, means this 2 cancel and here is dy dx ka whole square. So now separating the term, dy over dx ka whole cube and minus dy dx ka whole square and plus 1 equal to 0. This is the differential equation. So here we check the, this is order is same, in both term order is same. First term is first order differential coefficient, second term is first order differential coefficient. What we check the highest order derivative in a differential equation, but here is order is same. So order is 1. Order is 1 here. Order is 1. But degree, highest degree, same order there, then we check the highest degree. So degree is 3 here. Degree of this differential equation is 3. Now, formation of a differential equation. How we can form a differential equation? Differential equation can be formed by differentiation the ordinary equation. Any ordinary equation is given to you. What is ordinary equation? Means a relation in which two variables, one is dependent, other is independent, and some constant are there. maybe function also there. That relation is known as a ordinary equation. So any ordinary equation is given to me. There are two arbitrary constant or one arbitrary constant or more than one arbitrary constant. So our target to eliminate the constant in our ordinary equation. When we are eliminate the constant from ordinary equation, then we form the differential equation. If there are single ordinary constant, arbitrary constant, then we differentiate only one time the differential equation. If we have two arbitrary constant in ordinary equation, then we differentiate two times ordinary equation. Then we form the differential equation. Similarly, after eliminating the constant from ordinary equation, we can form the ordinary differential equation. So here I am giving some examples. Form the differential equation by eliminating arbitrary constant from given ordinary equation. First is this. Here in this question, we are giving y is equal to ax plus a square. This is ordinary equation. Ordinary equation. Ordinary equation is there. We have given. In this equation, a is arbitrary constant. A is arbitrary constant. Arbitrary constant. Constant. And y is dependent variable. And x is independent variable. So this is ordinary equation. This is ordinary equation. Now how we can form in differential equation this? So here we differentiate. Differentiating with respect to x to given equation 1. Here we get dy dx. dy dx. dy dx is equal to. Now a is constant. What a is multiply? First a is in multiply. So I am writing a. Differential of x is 1. And here is only constant. The differentiation of constant is 0. Arbitrary constant differential always be 0. So here we get dy dx. dy dx equal to a. This value putting this equation 2. From 2 putting in 1. Putting in 1. So y is equal to a. A is dy dx. So dy dx into x and plus dy dx ka whole square. This value putting here a. In place of a, we are putting value dy dx. So this equation is formed in a differential equation, ordinary differential equation. What equation 1 and this equation 3? Equation 1 is the solution of equation 3. We can say that equation 1 is a solution of equation 3. Next question, example 2, and discuss about this. Y is equal to a cos x and plus b sin x. So this is the ordinary equation. Ordinary equation we have given. Y equal to a cos x plus b sin x. From this equation, our target to eliminate a and b. A and b are arbitrary constant. A and b are arbitrary constant. Arbitrary constant. Arbitrary constants. So now here we 2 times differentiate this equation, then this ordinary equation convert in differential equation because here is 2 arbitrary constant. So differentiating with respect to x to 1 on both sides. On both sides. So here we get dy dx. This is equal to a constant in multiply. So a is not changed. Differential of cos x is minus sin x. And plus b is also arbitrary constant but in multiply this. So b cannot change in b. This and sin x. Differential of sin x is cos x. This equation is second. Again differentiating equation. Differentiating with respect to x. With respect to x. Then here we get d2y over dx2 dx2 equal to, here a is constant, and in multiply now minus sin x. Sin x का differential dy dx of sin x का differential is cos x, and dy dx is cos x का differential is minus sin x. So now here I am writing here cos x and plus b. Now here cos x का differential is minus sin x. So minus is common and we write here a cos x plus b sin x. So now from equation 1, this is y. This result is equal to y. So this is minus y. Here is d2y over dx2. So this term is taking this side. So d2y over dx2 and plus y equal to 0. So this is the differential equation. This is ordinary differential equation. We get this. So from an ordinary differential equation, we can convert in ordinary differential equation. So here is only two variable r comes and differentiating with respect to independent variable to dependent variable. Next one is the problem 3. We discuss this problem. This is also easy problem. Problem is given example here 3. So here y square, this is equal to ax square plus bx plus c. This is ordinary equation. This is 1 and this is ordinary equation. Here a, b and c are arbitrary constant. Okay. So now here are three constant, arbitrary three constants. So if we want to convert this ordinary equation in differential equation, then we differentiate 3 times, one by one. So first time differentiating with respect to x. So here 2 by y square, derivative of y square. Y square is 2y and dy dx. And equal to, here ax square, a is constant in multiply and differential is 2x, plus b is constant and this 1, and plus c is 0. This is equation 2. Ax square plus bx plus c. Now again differentiating this. Again differentiating with respect to x. So here be using product formula. In left hand side, be using left hand side. This is left hand side. So be using here 2 now. By f1 and f2. So y is constant, differentiate of this d2y over dx2 and plus this dy dx constant, differential of y dy dx. Differential of y is dy dx. dy dx of y means dy dx. This is differential of y. So here we write here dy dx and into dy dx. This is already constant and this is differential of y and this is left side and equal to, here is 2a. Here is b 0 and 0. So this is equation 3. Okay. So 2 is cancelled by on both sides. So here we get value of a. Value of a is y d2y over dx2 and plus dy dx का whole square. This is value of a. This equation is 4. Now this 4 putting in 2 from equation 4 putting in 2. Then we get, here is 2 by value of a here. Then we get b. B equal to this minus this. This is a value. So this minus this 2x. So here is 2y dy dx and here is minus this. Putting this value of b is there, this minus. So here is 2x. Putting value of a is this y d2y over. So we get this next. Now here, this is the value of 2 is cancel on both sides. This is the value of a. Again differentiating, then we get this result 0. So we are adding here, we get this equation. Now following methods, we are now ordinary differential equation. We are using several methods one by one to solve the ordinary differential equation. So we are giving here several methods which are very used and very interesting methods to solve the question a ordinary differential equation. Now method 1, that is easiest method, that is first step method. In any ordinary differential equation, which is the first order and first degree differential equation is given, these methods are applied in first order and first degree differential equation. We are discussing here first order and first degree differential equation. Our topic, our chapter is a differential equation of first order and first degree. So these are all methods applied in first order and first degree differential equation. So first method is variables are separable. This is very interesting method. This is first step method. Next method 2 is change of variable. In this method, we change an independent variable in one to another one. Then that method convert in first method. Change of variable, we apply change of variable method, then this method convert in variable separable. Same, if we applied any following methods, then our question convert in again first method is variable separate. Homogeneous differential equation. Homogeneous differential equation, when we apply homogeneous differential equation method, then this method again convert in variable separate. So we can say that variable separate is the first step method, and starting any differential equation, we apply only this method. Bernoulli differential equation, this is non-linear equation. We can say reducible to linear, means after some reducing in Bernoulli equation, that we convert in linear differential equation. So one by one we discuss all methods to solve the differential equation. Now method 1. First I am discussing the method 1. In this method, there are only 2 terms in the differential equation, not 3 terms. If 3 terms are given, then question is wrong. Only 2 terms are given. Each term the function should be in multiply. Each term the function are in multiply. There are only 2 terms, 1 point. Conditions. When we apply this method, conditions. Number 1, there are only 2 terms. There are only 2 terms. In total equation, there are only 2 terms. Next, second, the functions should be in multiply. Function should be in multiply. Okay. So now, if in any relation, this is basic concept of mathematics. In any relation, there are only 2 functions in any equation. So first function we are taking left side, and other term we are taking other side, right side. So there are 2 sides, left side and right side. What each side functions are given, and these are in multiply. So by cross multiplication, we can separate the function. After separating, the function are integrable, and then we can easily integrate the question. So here one example, this fx and this gy. This fx function and gy both are in multiply, and this dx and plus capital Gy and into small fx and dy equal to 0. In this example, there are only two terms. First term is this, second term is this. This is 0. So second term taking to next side, gy and into fx into dy and this minus sign. This goes to right hand side, so this is minus sign, and this fx and into gy and into dx. So here fx into gy and plus gy into fx, this equal to 0. So this term taking this side, this term taking this side, so this equal to minus sign gy and into fx and into dy here. Here is dx. So this dy. Here is fx and into gy dx. So here is y variable, here is x variable, here is y variable, but here is multiply. So by cross multiplication, we write this. Here is x integrating with respect to x. So here is fx and upon fx, small fx. I am writing this dx. So this part is integrable, we integrate this. And this equal to minus, here is gy and upon fx. So integrating this is dy. This is not. This is gy, small gy. So this is total function of y. This is total function of x. So this is integrable. Each side, the functions are integrable. Each side, the functions are integrable. Okay. Here is total function of y, and now here I am writing this type. So next one is here integrating on both sides. So basic formula of integration, in any integration, function is x and dx. So this is integrable function. So the answer of this is fx. Integral of small fx is capital Fx and plus c some or arbitrary constant. So this is the integration. So we can integrate this function. We can integrate here. So we can solve this equation. Now there are some problems depend on first method, variable separate. So I am solving these problems completely one by one. And problem 1. Problem 1. I am solving this. Here apply method 1 using method 1. Variables are separable. Variables separable here. So question is this: x plus 1 dy dx equal to x y square plus 1 and into dy. This question, this equation 1 is given. Now first time here writing 1 and cross multiply. We are taking cross multiply. Here cross multiply. After cross multiply, x plus 1 and here is dy equal to x y square plus 1 and into dx. Now here name of the method is variable separate. Here is dx but here is y. So variables should be separate. So now here is this. So dy here 1 upon y square plus 1. This function is goes to this side. This upon 1. So goes to this side. and here is dy equal to this function goes to this side, x upon x plus 1, and this dx. So integrating on both sides, integrating this. So now integrating of this result is tan inverse y. This is formula I am using here, integration 1 upon 1 plus x square dx. So integration, this is tan inverse x. So here we using this formula in this result. So tan inverse y equal to here. Here we write here plus 1 and minus 1. So we write here integration 1 minus 1 upon 1 plus x. This is partial fraction breaking this dx. So now here integrating 1 dx and minus integrating 1 upon 1 plus x dx, and here is tan inverse y. So now our answer is tan inverse y equal to integration of 1 is x minus this is log 1 plus x and this plus c. So this is the solution. Here is only one arbitrary constant c, because here is only one order and 1 degree differential equation. Now I am solving second problem with the same method. Second problem is problem 2. Problem is 2. So this problem is dy dx, this is equal to x into 2 log x plus 1 and upon sin y and plus y cos y. Okay. So here we are doing dx. Multiply, cross multiply here. First of all, cross multiply. Cross multiply. So here sin y and plus y cos y and this dy and this equal to x into 2 log x log x and plus x and 2 and dx. Now we are variables are separate here. Variables are separate in each term. Variables are separate in each term. Now integrating on both sides. This integrating equal. Integrating. So here I am writing here integration sin y and dy and plus here integration y cos y and dy. Okay. Y cos y dy. So this equal to here is 2 integration x log x and dx and plus integration x dx. So now here this integration I am keeping constant, not I am solving this, but this integration I am solving. Integration of cos y. Cos y integration is, cos y means sin y. Cos y ka means minus sin y. Integration of cos y means minus sin y. Y is constant. Here this is first function and this is second function. Integration of second, first is constant. We are apply this formula here. Integration first into second and dx. So we are apply integration of second and first is constant minus sin dy dx of first and integration of second and whole integration dx. Whole integration. So this is integration by parts. We are applying integration by parts. So here also we apply here this integration of cos y this and y is constant minus sin. Differential of 1 is 1 and integral of cos y is minus sin y. So here is minus sin y. And again integrating this. So this is cos y and minus sin y. So this integration is cancelled. Minus sin y means plus. Here is plus this. So sin y integration is cos y. Sin y integration is cos y and minus sin y minus y sin y minus y sin y, and sin y is cos y plus cos y. So equal to this twice of here. Here again apply the product formula. X is constant. Integration of x is x square by 2. This is constant. Now minus sign x square by 2 and differential this 1 upon x. So x is constant. Again integrating this and plus x square by 2. So now here 2 and here x square by 2 and log x, and here is only x, so x square by 4 and plus x square by 2 and plus c. So this is 2 cos y minus y sin y. This is the solution. Okay. So this is the third method. Next method is x dy dx plus cot y equal to 0. In next question 3, problem 3 is there. Problem 3. There is x dy dx and this plus cot y equal to 0. Cot y equal to 0. What initial conditions? Initial conditions are y equal to pi by 4 when x equal to root 2. These are initially conditions given in this question. If initial conditions are given in any question, it means we find the value of arbitrary constant and we get a singular solution, not general solution. In general solution, there is arbitrary constant are there. In a singular solution, arbitrary constant find out. So now x dy dx and plus cot y and this equal to 0. Okay. So this is given equation 1. Now cot y taking next side x dy dx, this equal to minus cot y. Now cross multiply this, then x dy is equal to cot y and dx. So variables, keeping variables separate. Variables separable. Method 1 apply here. So here is dy, here is x, here is y, here is dx. So dx this taking 1 upon x. So here is cot y. Any 1 upon cot y and dy equal to 1 upon x. This is minus sign is here. 1 upon x dx. Now variable are separate, so integrating on both sides. This implied that this is integration 10y dy equal to log x and plus c. 10y integration of 10y means log sec x. Log sec x का differential 1 upon sec x or sec x 10x. So 10y log sec y equal to log x plus c. This is solution. Now apply initially condition, putting y equal to pi by 4. So log y equal to pi by 4. Sec pi by 4 equal to log x. X is root 2 and plus c. So sec pi by 4 means sec 45. Cos 45 1 upon root 2. So this is there is only 2. So log is root 2 equal to log root 2 plus c. So this is minus side. Here is minus. This one is minus because here is minus. So minus. Here is minus. So here is minus. This is minus. So here is 2 log root 2. This is taking log root 2 and plus log root 2 equal to c. So c equal to 2 log root 2. This value putting in this equation. So final answer is log sec y, this equal to log soc by this equal to minus log x and plus 2 log root 2. This is the complete solution of the equation. This is answer. Next question, I am solving y minus x dy dx. Last question, last problem is there. I am solving last problem of this topic. So one method variables are separate is completed in ordinary differential equation. Next other method is change of variable. We have next discussed. So now problem is 4. Problem is 4. This is y minus x dy dx and this is equal to a y square plus dy dx. This is equation 1. First order and first degree ordinary differential equation this. We want to find out the solution of this. Apply the variable separate. We are using method 1. Method 1 is variable separate. So here now y minus x dy dx equal to multiply by a y square and plus a dy dx. This equation 2. Now in equation 2 we see that here dy dx in this term and dy dx in this term. So dy dx we are taking one side. So y minus ay square, this is equal to this term taking this side, x dy dx and plus a dy dx. So dy dx is keeping separate in one side so that we can take common. We can take common of this term. If same derivative are given in differential equation in more than one term, then we can take common. And now here dy dx is common. So dy dx is common, then there is x plus a. And here is y common, so here is 1 minus ay. 1 minus ay. Now this upon 1 and this upon 1. We are keeping cross multiply here. Here cross multiply we are doing. Cross multiply. Okay. Cross multiply. So here by 1 minus ay into dx is equal to x plus a y minus x into dy dx is equal to a y square plus dy dx. This is problem 1. This is differential equation. Okay. So now y minus x dy dx, this is equal to ay square multiply by a plus a dy dx. This equation 2. Here dy dx is more than one term, so we are taking separate of dy dx. This ay square to taking this side and x dy dx and plus a dy dx. Now dy dx is common. Here is x plus a and here is y is common. So 1 minus ay is there. So here is 1, here is also 1, cross multiplying this. So y into 1 minus ay and into dx and x plus a into dy. Okay, dy. This equation number 3. What keeping variables separate. Keeping variables separate. Variables separate. Here is x, but here is dy. Here is y, but here is dx. So we are again taking this by 1 upon x plus a into dx and equal to 1 upon y into 1 minus ay into dy. So integrating on both sides. Now here integration of this side is log x plus a. But in this side using partial fraction. Using partial fraction here. partial fraction. So now here we are writing integrating in bracket 1 upon 1 minus ay, and here is 1y. So here is writing plus, here is writing a. So this result is equal to this. This is dy. So now here integrating 1 upon y and dy, and plus a is common, 1 upon 1 minus ay into dy. So this integration log y and plus a, here minus log 1 minus ay upon a. So a is cancelled. So this equal to log x plus a and equal to log y minus log 1 minus ay plus c, constant, arbitrary constant. So this is complete solution. So this type we can solve the all ordinary differential equation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.